All right, so we left off talking about reaction, what we can do for rich and lean, and there's one other thing that we can do before I show you the next grouping of captures here as far as determining rich and lean conditions. We'll actually go back to the textbook here for a minute too. Here, this is it right here. If we look at the bank 2 sensor 1, so this is the same Isuzu, I think this was an Isuzu, right? Is that this case study where the 2 upstream sensors were reversed? If we look at the bank 2 sensor 1, what's it reporting? It's reporting a rich condition. I can't really see that myself. What about blue? Is that better?
Yeah.
So bank 2 sensor 1's reporting a rich condition, and I want you guys to notice at the same time, so I can't see my frame numbers here, that we're actually reporting a lean condition downstream. So think about that for a second, and let's look at the bank 1 sensor 1. We're reporting a lean condition, but the bank 1 sensor 2, the downstream, is reporting a rich. So let me ask you guys this. Is it possible that we could have, so here's my cat, right? Is it possible we could have a lean condition going into the cat and a rich condition coming out of the cat? Think about that for a second. Really? Okay, maybe we could say that it absorbed all the oxygen and you know, did its job. I don't know if that's I'm pretty sure that's not possible. How about a rich condition going into the cat and a lean condition coming out? Let me rephrase this. Could we have a fixed lean condition going into the cat with rich coming out? I don't think so. It's not possible. And it's the same thing up here. A rich condition coming in, constant rich, and a lean condition coming out. The answer is no. Do you guys understand I'm using the downstreams to tell me the upstreams are lying? So this is another method. I've given you 2 now. 1 is snap the throttle, look for the reaction. 2, look at the downstream. If it has dual cats, look at the downstreams, compare it to the upstream.
You sure you didn't put the cat on backwards?
No. This was just reversed upstream O2s. The next capture is after I reversed the connectors. My trims look great on short term. I don't like the long term numbers necessarily, and what I attributed that to was just fuel contaminated oil. After it running this way for a long period of time, our PCV system is going to be contaminated with fuel, and this is the PCV system really kind of in action here. We changed the oil, these numbers should come down. So something to remember when you encounter rich conditions is an oil change should always be done. And these are the after numbers of my upstreams, my downstreams. And guys, these look great. I like these. Again, frequency, amplitude. I'm just looking for, are they moving up and down? How is my this is 0.065 and this is 0.930. How's my amplitude on that one? I think you can see that number. 0.05, 0.93. How's my amplitude? That's good. That's 50 millivolts, and that's 935 millivolts. I'm okay with that. Remember, I'm okay with below 200 and above 800, just not inside that window. What about frequency? Do I know what these frames mean? Even if I showed you frame numbers, do I know what time is? I do not. But do they look better than they did a few minutes ago, which were flatline? Yes, they do. And this is what we want to see on a cat. This is a good working cat. Guys, this is not. Is it possible, though, that that cat is burning off contaminants now? And it is possible that that thing may come back to life. And I didn't care. I got the vehicle running right and gave it back to the garage. Keep track of your O2 connectors better. The engine was replaced. I forgot to tell you that. Right? In both examples I've given you, someone was doing some type of exhaust work. If you're changing the engine, you're unbolting the exhaust. So. Back to my text. Next segment, let me introduce it to you. We're talking about it already. If we have a fixed O2 signal, it's fixed rich on page 4, page 5. If it's fixed lean, what is the first thing that we think about? What's the first thing we ask ourselves with a fixed rich O2? Is it actually rich? Or is the sensor lying? Do you guys know what I mean by lying? False rich. A rich signal from the O2, but the O2 is actually dead. That's what I mean by lying. If the sensor's lying, you can write a note in there if you need to, right under that question. What do I mean by a lying sensor? A lying sensor would be one, in this case, that's reporting a rich signal, but it's a dead sensor. Sensors become contaminated, and they can do this. You can have an O2 fixed rich and it not be a rich condition at all. So do you understand, before we would chase a rich fault code, and by the way, our rich codes are P0172 and P0175. This is bank 1, this is bank 2. And what are these? These are rich diagnostic trouble codes. If you have a rich fault code in memory and you look at that O2 and it's flatline rich, before you chase rich conditions, which would be higher than normal fuel pressure, a ruptured regulator diaphragm, leaking injectors, evap purge problems, etc. If before we would chase that, we want to make sure that we check this sensor for reaction. Okay, sorry about that. Questions on what I'm describing so far? Do we have a rich condition or do we have a dead O2? That's the question. It's the same question on page 5. Do we have a lean condition or a dead O2? And in both cases, we can have that. So I'm giving you tests that you can do. With a rich condition, if we can lean the mixture out and look for a reaction, that would be helpful, right? So what am I telling you to do? Make a vacuum leak. See if the O2 responds. There's variables to that though. And variables would be, if it's extremely rich, you can put all the oxygen you want to that engine and it won't drop the O2 lean. I had a Ford truck that had 90 pounds of fuel pressure. Spec was 35. Student's vehicle. Looked at the O2, it was flatline rich. It was like 900 millivolts. Pre-OBD2 Ford, so I had a scope on it so I could see it because they didn't give you data. And when I did the vacuum test, all I saw was a little blip. Right there was where I made the vacuum leak. What we want to see, we want to see a signal that would do this. And it just gave me a little bit of a drop. And so I told him to replace the oxygen sensor. It was late in the day. And of course he comes back the next day with the same fault code, rich exhaust. We blew the call. It had 90 pounds of fuel pressure. Why didn't this make a vacuum leak test work? It was too rich. I pulled the brake booster hose off, and even that didn't make it go lean. That's how rich it was running. So we need to come up with some other methods, wouldn't you agree? I just gave you one. If you're upstream, if it's got a, dual cats and you're looking at one bank, and that's going to be the key. It has to have duals. If you're rich going into the cat, you're not going to be lean coming out of the cat. If you're rich going in, the downstream is also going to be showing you rich on flatline conditions. Okay? If you see lean coming out, that right there is suggesting the sensor's lying. Another one would be look at tailpipe CO, and we need to talk about that for a second before I give you my case studies. Let's jump down to here. It's actually pretty easy. This is from your Pennsylvania State emission book. This should look familiar for you guys that just came out of emission class. The only thing that I'm going to talk about with this is the CO and the O2. And you need to remember this for your test because I asked you this too. Your CO is your rich indicator. It's listed right here. Your O2 is your lean indicator. By that, I'm saying with these gases, if we're looking at tailpipe gases, there are two standalone gases. Meaning, if I have my CO measurement, I know which side of stoich I'm on. And if I have my O2 measurement, I know which side of stoichiometric I'm on. Can I say that with hydrocarbons? I cannot, because, and by the way, this green line comes up. If I am here or here, isn't this the same level of hydrocarbons on both sides, rich and lean? You cannot look at hydrocarbons alone and tell me which side of stoichiometric you're on. You can't do it. It's high on both sides. I can't look at CO2 and determine which side of stoichiometric I'm on by itself. And then here in Western PA, we don't measure NOx. This would be in Philly area where they do their dyno testing. I've never done a NOx measurement on the tailpipe, so that one to me is irrelevant, but you can see that you can be high, right? Same level with NOx on both sides. You guys understand what I'm saying by standalone gases? If I look at the CO measurement, can I tell which side of stoichiometric I'm on? Absolutely. If I see any COs at all, which side of stoich am I on? Rich. What is CO? CO is gas burned without enough oxygen. It's carbon monoxide. If I look at my oxygen content, not my oxygen sensor, but my oxygen content, if my O2 content is high, can I tell which side of stoichiometric I'm on? Yes, I can. There's a variable to that, and that's air pumps and misfires and false lean conditions, which we'll talk about. But those are the two standalone gases. What are we doing from here to here, guys? What's changing? The 1 is fuel, so what's the other number? Air. So 10 to 1, 11, 11 to 1, 12 to 1. You guys follow? What are we doing along this chart? Going this way, we're adding air to this mixture. If we're adding air, adding oxygen, why is the tailpipe oxygen level? So I'm looking here. If I'm adding oxygen, why is the tailpipe oxygen levels not increasing? This is before the cap. That's a good point. These numbers, these gas readings are pre-cap. I'm adding oxygen to a rich condition. What are we creating? We're creating CO2. And what happens with CO if we're creating CO2? So we're adding oxygen. We got high CO because there's not enough. But as we add this oxygen, we're now making CO2, and CO is coming down. You follow? I'm not a chemist, so this is as good as I got. As we continue, we add oxygen, we bring the CO down, and then we hit a point where we add oxygen that all of a sudden the O2 level starts to rise. Why? You guys see that there's no CO left to convert? So we flatline on the CO and we start to climb on the O2. These are just good indicators. Here's my point. Can I use tailpipe emissions to tell me if that sensor's lying or not? If I have an O2 that's fixed rich, and I have a CO percentage in the tailpipe at all, any percent, so I get that a lot. Well, what's good, what's bad? In a perfect world, CO percentage should be 0, and O2 percentage should be 0. PA emission, when we did tailpipe testing, anything more than up to, let's see, it was like 94. So 1.2% or more equals a fail. And then 94, 95, right before OBD2 came, actually they didn't start doing OBD tests until like 98. So we were still doing tailpipe tests on OBD2 cars before the program came out. And they dropped that to like 0.8% or above equaled a fail on the newer car. So I'm only giving you that number for a perspective of how much, say, 10% is in my captures coming up. How much is 10% if less than 1% is a fail? I think we can all understand that's a pretty high number. So if we see, say, 4 or 5% CO percent is 5%, and we see an O2 that's flatline rich, say 900 millivolts, is the sensor lying? tailpipe gases are saying rich. O2 is saying rich. Sensor's not lying. What's a lying sensor look like? If it's at 900 millivolts and you see an O2, here's one. This one's about 800 millivolt, pretty crappy looking signal, and I have a CO percentage that's 0. That sensor's lying. What happens when a sensor is reading 300 millivolts? It's about 0.3. That's a lean signal. What's the computer do with a lean signal? Right? Lean signal equals what? This is on page 7, by the way. Lean signal equals add fuel, right? Is the computer adding fuel? Look at my CO percentage, 10.7%. Is it possible to have oxygen, lean, in a 10.7% CO environment? It's not, because what happens when we add oxygen? We bring CO down. That's what this chart's showing us. You're up here. There's no way that you have oxygen. That sensor's lying, so I'm giving you tailpipe readings for that. With a rich signal, what's the computer do? It can't add air. Take fuel away. Are we seeing that? In that I have no CO. Now, it would be nice if my oxygen sensor reading was working on here. I don't think it was. I would have expected an elevated O2 reading here, but all right, so let's go back a page. Do you understand what I'm saying here? Compare tailpipe, back up one more. Compare tailpipe CO to O2 voltage. O2 sensor response testing will be the first video that I'd reference you to. Leaking fuel pressure regulator, so we see what's coming, right? This is going to be an actual rich condition. So let me be clear on my text here that if we are dealing with a fixed rich O2 signal or fuel trim trouble codes, I want you guys to take note of this, right? I'm saying negative fuel trim numbers and or higher than normal O2. I want you guys to remember you can follow this page even when you don't have a fixed O2 signal. If you have negative fuel trim numbers and you're not sure where to go, this is any car. Scott, this is your car too that we're thinking of. You had negative 19% on your car and we're not sure where to go. This is where we go in my book. Section 5, page 4, and remember the first thing we checked on your car? Fuel pressure regulator. I was thinking that right from the get-go. Notice that's on my list, a ruptured regulator diaphragm. So remember this list is here. Yours end up being a jump chain, which we'll talk about tomorrow. Okay, so if our sensor reacts, so let's go up here. If the signal voltage drops when you make a vacuum leak, how's the sensor? Fixed rich O2, make a vacuum leak, sensor reacts. How's the sensor? It's good. Can I, instead of making a vacuum leak, can I flutter the gas pedal? And by flutter the gas pedal, I'm saying rapidly pump the throttle. So maybe add that in here. Instead of this, this would be really, this should be 2, I guess, huh? 1 and 1. That should be number 2. Is yours like that too?
Yeah.
That's a misprint. 3 would be, let's add a third one. 3 would be a rapid throttle test. I don't know if would you know what that means down the road? Rapid snapping of the throttle, maybe add that word in there. Flutter the gas pedal. I would write flutter if I knew how to spell it. So that's why I'm not writing. Flutter.
I'd give
2 D's or 2 T's? I apologize for my horrible spelling. 2 T's? All right, so flutter the gas pedal. Flutter the gas pedal. My son is very good at spelling too, and I don't get it. I just don't get it. He does, and he makes fun of me all the time, and him and my wife make fun of me, and my other son is the same as me. He sucks at spelling too, so anyway. So what are we doing? When we rapidly flutter the gas pedal, we are adding fuel, we are adding oxygen. We should be able to make an O2 react. I showed you guys that in that Isuzu video we just did, right? That's what I did with those fixed signals. It works. So if it reacts, how's the sensor? That's what we're addressing here. If it reacts to a mixture change, how's the sensor? It's good. And if our I don't do this often, guys. This compare tailpipe CO to O2. I don't do it often. I don't think it's really necessary. It's another way you can do it. These top two I'm fine with. This rapid throttle test I think works better than a vacuum leak because we can get into a fuel cut mode with the rapid throttle test that we can't do with making a vacuum leak. In other words, I can make the fuel shut off completely on a decel on a fuel injected car, and I'm looking for that reaction on that O2. So I think that's probably better. Once we say the O2 is good, do you guys understand that's when we go to this list to the right? If we say the O2 is bad and not reacting, it's not time to change the O2. What we need to do is we need to check the heater circuit, we need to check the signal and the ground for opens and shorts before we replace that faulty O2 sensor. Think of the case studies we just talked about. We changed those O2s that with reverse connections that wouldn't have fixed it. What led me down that path was checking heater, power as ground, noticing the connectors were plugged in wrong. When we find a lying O2, it's not time to change the O2 is what I'm telling you. Now, you want to play your odds and roll the dice and you figure out that that O2 is not reacting, then change the sensor and probably 8 times out of 10 you'll be right. But there will be 2 out of 10 that will have a wiring problem. And 80% isn't good enough, especially if it's your car. Are you happy with 80% if it's your car? You got to spend $100 on a sensor, or are you going to do one more check that'll take you 5 more minutes to do? All right, that's what we need to do. So O2 sensor response testing in this car, as we see right here, leaking fuel pressure regulator. What do I have listed in my book? Ruptured fuel pressure regulator diaphragm. That's where we're going with this video. Next page. O2, what do we see? I don't see a flat line on that O2 at this point. This is a still capture. What I do see is a long-term trim of -13. Can you guys see that? -13%. So are we in this rich condition mode? We are. What happened here? Open loop. Open loop. I'm not sure why I took that picture. Next page, looks like we went into maybe closed on -13. There's another shot, -28. It's pretty rich, isn't it? Here's the question. Is the sensor lying? So there's 820. I have a flat line up here. This is a flat line rich signal. You guys with me on that? Is the sensor lying, or do we have an actual rich condition? Do I show it? What am I doing in this step? I'm making a vacuum leak. I'm pulling the brake booster hose off. So I pull the brake booster hose off and I let it run a little bit, but right there is where I pulled that brake booster hose off. How is my sensor? Sensor's good. So what do we have? An actual rich condition. The sensor's not the problem. So what's the most common cause of a rich condition? What am I pointing to? Fuel pressure regulator. Okay? The diaphragm's rupture. I pulled the hose off, and this is it looks a little wet in that area. Let's see if we can see the difference in the captures. Can you see the puddle of fuel that is now in that area? The video really emphasizes it. You can see it had a bad regulator on this car. And where they rupture internally, I think I can show you that real quick. I just pulled this up, actually. this open already. This is off of a video I did. That's what happens to those diaphragms internal. See the split in that? What's it allow fuel to do? It allows fuel to come up through. All right, so that's what you're looking at for a ruptured diaphragm. I destroyed it taking it apart, but you see the deterioration in the rubber, and I guess I really didn't need to show you that right now. But so what do we have with this car? A good O2, it wasn't lying, had a rich condition, we found it. Next one. Fixed rich O2. Is the sensor lying? So these videos follow exactly what we're teaching here. This will be in the section 4 and 5 playlist on my free channel. Fixed rich O2, is the sensor lying? We good with where we're going? Let's do some tests. See what I do first. What am I looking at? Let me get my perspective. Looks like 97 Mitsu Eclipse. I'm looking at my upstream O2. So this is a 4-cylinder, so only one O2. Where I'm pointing right now is my sensor. And you can see that there's some reaction there. It looks like maybe I did a little snap throttle. But notice it's not dropping any lower than, looks like 508. That says 508 in that picture. 508 min. I'm looking right here, 508, and this is 918. Next page. I'm looking or pointing at the long-term trim. See the long-term at negative 24%. This is minus 24%. So we have a rich O2 signal. Remember, any number above what is rich? Any number above 450 is rich. So 450 and above, what's the computer going to do with that signal? Takes fuel away, right? Are we seeing that in the long-term trim? We are seeing that in the long-term trim. And I want you guys to notice the rear O2 is saying lean right now. A rich upstream, computer's taking fuel away. Downstream saying lean, that's suggesting that sensor's dead. Fixed conditions, you're going to see the same thing downstream. It'll flood the cat. So that's what I'm pointing to. I'm using this as a guide, right? We need to add a note. We need to add a note in my book on this page. There's another one. We have 3. What's the 4th? Rapid throttle. So make a vacuum. They compare tailpipe CO. 3, rapid throttle. What's 4? Look at what? Look at your downstream O2. On what kind of system? On a dual cat system. Or on a single cat system that's one bank. 4-cylinder engine. I'm almost done. We have a bunch of shop work to do today. We have that car that I just signed the paperwork, a Mazda Millennia to no start. We have to finish this Cobalt. Debbie up front has a car with a check engine light on. We have a Honda out here with a running problem. A Neon with an intermittent no start. Ricky's friend's bringing a 300 in with a 4-cylinder misfire. Yeah, we're going to be busy today, so let's finish up. You guys understand why I'm pointing at and talking about the downstream O2? I see a discrepancy here. A fixed rich upstream and a lean downstream. That's suggesting my upstream is faulty. What's my gas pedal test? Notice even in my notes last night, I wanted to say the flutter the gas pedal, but I didn't know how to spell flutter, and I didn't want to be embarrassed in front of you this morning if it was spelled wrong. So what's the gas pedal test? What am I doing?
Fluttering.
I am fluttering the pedal. Do you guys understand what I mean by flutter? When I tell people to do this test, they'll rev the engine, but they do it too long. They'll put the pedal down, they'll let it go to red line, then they'll let off, and then they'll do it again. That's not what you want. You want a rapid fluttering of the pedal. You're not even worried about the RPM. You're doing the XL fuel enrichment, decel fuel cut kind of thing with the TPS, and that's what I'm doing. Can you see the downstream sensor is reacting properly? By the way, this is how we check downstream sensors. You know, how do you check a downstream sensor for a reaction when you have a cat there that's doing all that work? Is you flood the cat with gases it can't consume. And so how's that downstream sensor? Is it reacting? If you have a downstream sensor fault code, this is the same kind of stuff you do. But look at my upstream. Can you see that my upstream is never going below 508? I cannot drive this upstream sensor lean. Okay? So it failed this test too. And this is just a more zoomed out picture of me fluttering the pedal more. And then I did this one. This is tailpipe gases. Just to reinforce what we're talking about. What's the gas we want to pay attention to for a rich condition? CO. Unfortunately, these O2 sensors in these gas analyzers, there's actually an oxygen sensor in the gas analyzer. It's the one piece that needs to be replaced. And this one's dead too, so we can't use that number. But what's this 0% CO telling me? If my mixture is rich, right, that's where we started. What's the case study? Fixed rich O2, what do we have? We had fault codes. I didn't show the codes on this. Negative 24% fuel trim. Is the engine actually rich? It failed the gas pedal test, and it failed this one, telling me I don't have a rich condition. Is this a good sensor or not? It is not a good sensor. And what am I doing here? Looks like I had a reaction doing what? I don't know what that is. Oh, is this a different car now?
Can you read the bottom?
Fixed rich O2 is a sensor lying. Is that
on the scan tool? What's it say that you can read on
Oh yeah, 97 Mitsui Eclipse. No, that's the same one. Looks like maybe we go from closed loop, open loop. There's some loop status changes, I think, at that. I thought I showed the... Okay, I got it. Next page. What am I emphasizing here? What are we doing now? Same car.
Check the wires, check the heater.
I have a confirmed O2 problem, right? Is it time to change the sensor, or should we finish and check the wiring? Heater powers, heater grounds, signal ground. This is what I'm doing. Watch the video for the rest of it. I'm just pointing that out. This is my signal ground, is 0.05. What's the spec I've been giving you guys for signal ground wires so far this term? Signal grounds equal 100 millivolts or less. 0.05 is my number here. How's that sensor ground? Sensor ground is good. Next one is my signal wire. It's fixed at 1.51. That's not an issue. I mean, it is an issue, but it's not a concern wiring-wise, because that's what the scan tool was reading too at this point, was the same voltage. There's another capture, 1.29. That's the signal. This is my O2. This is heater power. How's this one? Car's running. Heater power test. What do we see? This says 1257 down here, 12.57. How's that heater power? That's good. Heater ground, this is 0.37. That's 0.37, that's this number right here. That equals 370 millivolts. Does that contradict the number I just gave you? I said sensor grounds, 100 millivolts or less. Is the heater ground a sensor ground? I know it's part of the sensor, but it's not a signal ground. It's a load, 1 to 2 amps of current. You're going to have higher ground voltage on higher amperage circuits. That's normal, that's good. What's this car need? Car needs a sensor. We're done. Okay, 5 extra minutes. Another one, fixed rich. Which one's fixed rich? Can you see it? This is a V8 Chevy van, I believe. It actually might be a 6-cylinder. This was Jimmy Hall's van. You know what his complaint was? 3-cylinder misfire. Intermittent. And it had him running circles for a little bit. 3-cylinder misfire. And he showed it to me. He brought it in. It was missing real bad. He did an RPM drop test on the passenger side. Unplugged injectors or the ignition, I can't remember. And there was no RPM changes on one half of the engine. He thought it was something mechanical, but it was intermittent. Turns out it's a dead O2. Look, bank 2 sensor 1. What's it reporting all the time? Rich, what's the computer do? What's the reaction of the engine computer? Take fuel away, right? But we have to ask ourselves, is the sensor lying or are we actually rich? Here's what I'm using. Check out my bank 2 sensor 2, the downstream sensor. If you're fixed rich upstream, I promise you your downstream will also be fixed rich. And what is this telling us? This is telling us the sensor's lying. Why would the downstream be fixed lean? Because the computer's reaction to a rich signal is to do what? Take fuel away. And if the computer's taking fuel away, won't the downstream be flooded with a lean condition? And that's what's causing that. This is a dead O2, comparing upstreams and downstreams. And then reinforcement here, guys. You would swear by the smell of this exhaust that it was rich. It wasn't. Look at my CO percentage on this van at this point in time. Right where that O2 is rich. 0. Now my O2 is dead, as you can see. That'd be nice to look at that. Why does it stink so bad? Look at the hydrocarbons. Hydrocarbons are unburned fuel. Unburned fuel. You get to a point of a lean misfire. Right here. Do you see on this graph how they make the HCs all weird looking? That's your lean misfire point. They'll go through the roof. You don't have enough oxygen, or you have too much oxygen in that mixture, you'll put the flame out. When you put the flame out, what are you left with? Unburned fuel. And it stinks and it smells rich. Don't use your nose here. Another shot of that. It's a pretty high number. For an emission failure, by the way, just to give you a perspective of how high 4,000 parts per million hydrocarbons are, 220 was your limit. And then with the OBD2 cars, it was 120 or 180. I can't remember. It's been a while. Pretty high number, though, isn't it? Can you handle one more? Too bad. One more. One more. Low power, intermittent, no start case study. This one's fixed lean. This is right where we are. So with the fixed lean one, what do? This one's a little different. We're not going to make a vacuum leak if it's already lean. We need to add a fuel source. Add propane into the intake. Richen it up. See if you have a reaction. That one works perfect. There is no variable I can give you where you cannot fuel the engine enough. Like we can't lean it enough. I gave you that example, but in this case, I'm good with this test. Will the flood or the gas pedal one work here too? Can we do the gas pedal test here as well? Yes. And 4. Can we look at downstream downstream O2s? Use those as a guide. Same thing. We're asking ourselves, is the mixture actually lean or is the sensor lying? Is the sensor lying? This one ended up having a plugged Cat 2, and that's why that question's there. What do we see? This is a pre-OBD2 1990 Buick Skylark. I see a lean exhaust code 44. So let's take a look.
Quad driver, what is that?
What's that?
Quad driver module failure, what is that?
I was afraid you were going to ask me that. I promise I can do this in 30 seconds. What's a quad driver module? Remember in section 3 we talked about a device that I called an output state monitor. You guys, in my book I have a thing here in a box and I call it an OSM. You remember that? What's the output state monitor? It's monitoring that output for opens and shorts, right? in these early GMs, they would take 4 different circuits, 4 different drivers, and they were all monitored. There would be in there would be one here, one here. And all 4 of these would be monitored by one, what they called QDM. What is that? It's nothing special. It was an old GM. I remember when these first came out, people were like, quad driver, this computers are crazy now. It's just an output state monitor is all it is. A QDM fault on this car means one of those 4 outputs has an open or short. So then you get a diagram and you figure out which outputs are on that particular QDM. It's no different than today's cars when you have a open or shorted solenoid. How's the computer know that? It monitors it. Cool? See, that was like 30 seconds, wasn't it? And if you have any questions on that, too bad, wrong topic. Go back to section 3 if you want to learn more about output state monitors. Let's keep going. Cool? Okay? So what are we going after? Lean exhaust fault code. Okay? By the way, no, never mind. Somebody left the tranny plug unplugged on that. That's what that tells me. The second gear switch and that torque converter clutch are in that same circuit, and these were known for torque converter clutch solenoids that would stick and people would unplug them and it said a QDM fault. Anyway, that was not really important to you guys, so you'll probably never see one. Next page. What are we seeing? I'm seeing a, let's see where we at. Let me get my perspective. An O2 right here of 4 millivolts is my current number. See, I'm flatline lean. I had some activity there. I'm in open loop right now, so my integrator at 128. What's 128 equal? 0%. Block learn is not in this picture. Next page. Integrator at 151. Where's my block learn? 149. What kind of commands are those? Numbers above 128 are adding fuel. Is the computer adding fuel to this lean O2? My O2 looks pretty crappy. 363 millivolts on average. I'm barely getting past that point. I don't know if we would call this fixed lean. There is some activity. I attempted to show the tailpipe gases at this point. I don't know if you can see the black cloud. Can you kind of see the grayish cloud coming out of that tailpipe? In the video you can see it. If you see black smoke coming out of a tailpipe, is the car running lean? No, it's not. Is the sensor lying? Yes. Do we need a tailpipe gas analyzer to tell us that? Probably not. I guess that's the end of that one. I thought I showed the gas in that one. I did.
I thought it was a diesel.
It's not. I lied. One more. That one was quick. Look. What's this one? Fixed lean. And what did I write here? A video that didn't make it. Except I can use it here. I was pissed that I missed this. That sometimes when you do these, the sensors will start to work again. And that's pretty common. So that's what happened with this car. Same kind of scenario. What do I see? A fixed lean O2, 0. Notice the downstream's doing what at this point? Why is it climbing? What's the computer do with an upstream that's lean? Starts to add fuel. Do you see 24% on the short term? Should have had that there. Maybe you see it better. What am I doing here? Yeah, I'm looking at a low voltage. This is the period we're focused on right there. Upstream is reading lean. What's the computer do with a lean condition? A lean signal equals what? Computer will add fuel. Are we seeing that with the downstream? A rich downstream. We are. And then check out my tailpipe CO. And that's it with this one, guys, just so you're comfortable. Why this didn't make it, I'll show you in the next image. During the fixed lean O2 condition, what do we see the tailpipe CO percentage at? 11%. So is the sensor lying? Yes, it is. It's a dead sensor. Check the powers and grounds, same routine. The reason this didn't make the video, as soon as I started filming, that piece of crap sensor started working again. Look at that picture. This right here. That's my O2. And you see how much better the CO numbers are now? So
you still replace the sensor, right?
yeah, it was a bad sensor. It just never made it into a video because the sensor started working again and I couldn't recreate it after trying 5 or 6 times after this. That's what happens with O2s.
Just whack it.
O2s will fail sometimes after extended drives, and then you get these cars in and they work great. And sometimes you get O2 codes. The answer is to be a parts changer. I hate to say that, but sometimes you get an O2 fault code. I'm not talking about rich and lean trouble codes, the 171, 174, 172, 175. I'm talking about when you see like a lack of O2 switch, slow response type trouble codes. To be honest with you guys, I've been a parts changer with a lot of those. I don't like to be, but if you can't duplicate the fault, what's your next step? What's the most logical cause of a slow response fault code that you can't recreate? It's about O2, so you change it. You know, don't forget about vacuum or false lean conditions. Tomorrow, our test will not be tomorrow. I need one more day with you guys on this subject. When you guys come back tomorrow, here's where we're starting off. We're starting with our actual lean. So this list to the right, we need to talk about because I have false leans in here. I also need to correct my EGR in here. I think we did already though. You guys should have notes on that, right? Section, I made you guys add, we already did correct the EGR and the
stuck open EGR.
Stuck open EGR on a MAF engine, stuck open EGR on a speed density engine. You have those notes, right? Okay, cool. And then we need to talk a little bit more about this list. The actual lean conditions. What's left in this chapter, guys, is the heater, power, and ground checks and circuit integrity. And the circuit integrity is pretty cool. I think, Derek, you were watching when I was in the one video where I was touching the battery, and I think you were in here when I was pulling up those pictures. I was using my body as a resistor, and I was forcing rich signals into the O2. It's actually a really cool test. Really important lecture tomorrow, the rest of this chapter. It's again, wiring and circuit integrity is what we have left, and then we'll take our test.